All right. So, what tends to happen after we do the map activity is people get this inflated sense of confidence in their ability to do vectors because it's just perpendicular stuff and you're actually physically measuring a lot of it. And then when we go back to doing the vector components, the world comes crashing down a little, okay? And that's okay, it's all right. Vector addition is a slow process and there's lots of things to remember. Okay? We don't want to skip any steps or things like that. But in the end, guys, it's usually the diagram. So something you can do that doesn't involve you having to do all the math every single time, okay, is just go over the questions and just draw the diagram. Okay? I mean, in the end, I don't want to interrupt. Okay? In the end, you can tell by the answer on your worksheet whether you've drawn the picture correctly or not. Okay? I have full confidence in your guys' ability to do all the math in those questions. It isn't hard, it's just punching into the calculator. It's the diagram. Okay? Like inevitably, for probably anyone who didn't do well on one of those questions, it was the diagram that screwed you up. Okay? Well, just practice drawing the diagram, look at the final answer, go, okay, does my resultant go north of east? Oh, okay, well I drew it right then. Okay? And then it doesn't take you 25 minutes to do the whole question, and you get more practice with the hard part, which is the drawing of the diagram. Okay? So it's worth doing. Okay? Everyone's gonna follow me there? Okay. All right. Now, diagrams. This one is a tricky diagram. Because this is five vectors. 5 vectors. Okay? Let's see if we can just get the diagram for that. Okay, it's good practice for the diagram. Remember, everyone should draw compass rose. Never eat soggy wieners. Okay? And figure out which direction everything should go. Okay? I'll give you a few minutes and then I'll draw the diagram up here as well. Okay, so we start out with 25 meters at 30 degrees west of north. Okay? I'm going to start like way over here. Okay, I'm going to go 30 degrees west of north, so something like that probably. And that'll be 25 meters. Then I'm going to go 46 meters at 18 degrees south of west. So okay, then 10 meters south. And I'm trying to keep my scale about right here. It's not great, but it's close enough. And then 18 meters at 40 degrees east of north. Okay, so that would be north, and 40 degrees would be about there maybe, and 18 meters should be twice as long as that one about, so something like that. Okay, X, Y, 40 and 18, which means that my resultant goes here. Now, it didn't end up being, like if I'm looking at the answer, my triangle's a bit off, but it's still generally right, okay? My final answer does say it's north of west, okay? And it does say it's 46 meters, and this line and that line are, they're close. My angle's not great. It's a little too big for 14 degrees, but it's generally right, okay? It gives me the right impression of what's going on in this question. So there's theta, okay? There's my displacement, there's x, there's y, okay? Diagram should look something like that. Probably should have been maybe a little bit lower here. Maybe it should have been more like here, okay? But it worked out okay. Okay, for a freehand, not measured sort of scale diagram, it's generally giving me the right impression. Yep. All right. How did people do on that one? Yeah.
I mixed up the 14, 40, and 80 for degrees. But
Okay. Yeah.
Looks exactly like first.
All right. Let's rather than because I don't. The only one I want you to do here is C. Okay. Only want you to do C. Calculated speed.
Is it still the 2.5 minutes you were pushing?
Yeah, it's still the 2.5 minutes. Yeah.
So we just
So turn the minutes to seconds. Okay, we done?
yes.
Yeah, because calculating speed shouldn't take very long. Because speed is distance divided by time. It's scalar. I don't need to do any of that crap that we've been doing, okay, on any of the other questions. On this one, all I have to do is go 25 plus 46 plus 10 plus 18, okay, and then divide that by 150 seconds. Yeah, 150 seconds, okay. Boom, 0.66 meters per second.
Man, he's slow.
Well, but he's going all over the place.
Yeah.
Yeah.
And he's carrying a golden idol.
Yes, you know that thing that was about the size of a football. I don't know if you guys have seen that movie.
Pretty small.
Yeah, it's pretty small, but it'd be heavy. Okay, gold is heavy. If you like, and that would be bigger than a gold bar. It would be just, you know, like maybe heavier than a gold bar. Those are like 30 pounds or something like that, right? All right, let's see. I'm gonna just put a couple of questions up here, and all I want you to do is draw the diagram. Okay, we're just gonna practice drawing the diagrams because I've got confidence in your math.
Once you get back in the go.
Yes. Okay. Okay, I would like you guys to draw the diagrams for number 1, for number 4, and for number 5, and then we'll do the boat question after that to review both questions. Okay, so we're not actually solving these three, we're just drawing the diagrams for those three. Okay, give you a few minutes. Okay, so on number 1, okay, it goes 25 kilometers at 20 degrees north of west. So if I'm, doing that compass rose thing I told you to do, north of west means I put my pencil on west, I move north of it, boom, there's my first triangle, so I draw my reference line west, I go 20 degrees north of that. Okay, that's 25 kilometers long. There's X, there's Y, and then it goes 10 kilometers south. So, okay, that would be the vector diagram for that question. Okay, everybody all right with that one?
Yep.
Okay. How many people are done number 4? Okay, let's have a look at that one. So, 10 kilometers at 8.5 degrees south of west, and then 30.5 degrees south of west. So everything is south of west. Okay, that makes it pretty straightforward. Okay, so I just draw a line that's west, and I go 8.5 degrees south of that, so that's a pretty narrow triangle. Okay, there'd be X, there'd be Y, and this would be 10 kilometers. And then 7.5 at 35 degrees south of west. So which would mean my overall resultant would go like that. Okay? All right, some people have done 5. Okay, I'll give you another minute here on 5, and then I'm going to draw 5. Okay, is scale important in this one? Yes, absolutely. All right, so we're going to start off with 30 degrees north of west for 250 kilometers. Okay, so I'm going to draw my reference line due west. I'm going to go 30 degrees north of that. Okay, and then my other vector is 123 kilometers at 75 degrees south of east. Okay, so here's my reference line east. I have to go 75 degrees south of that. I drew that way too long. Okay, so 75 degrees south of that is going to go like here. Okay, it's a long way. It's only 15 degrees shy of being straight south. Okay, south of east. And it's only 123 kilometers long. So it's half the length of this one. Okay? Everybody with me there? All right, now, here's the tricky part of this. That 123 kilometers is very close to this length. Right? So in a situation like this, if I'm not sure and I don't have the answer to work back from, okay, I do this. I actually calculate what this y will be. Right? For this one, I go sine of 30 times 250. Well, sine of 30 times 250 is 125. Okay, so I know there's no way this line, which is angled, can be longer than that side of the triangle. So it's going to end up like down here somewhere. Okay, that will be the triangle for that. I'm not even going to need this part. Okay, here's X, here's Y, 75 degrees, 123 meters. Okay, and then my resultant triangle would go like this. Okay, it's pretty narrow, which fits with the answer. Okay, so there'd be theta, this would be y, this would be x, okay, and then I'd go about doing my calculations. Okay, everybody with me on that one? That's if they're tricky like that one, where scale is so important. It never hurts to calculate a side to help you. Okay? And that's what I would do for a question like this. If I wasn't sure, in this one it's really close. Okay? I mean, it's 1.9 degrees, like that's virtually straight back down. Okay? I would just calculate a side to check. Okay? It never hurts to do that. All right, making sense? Diagrams are tricky. Okay? I get it, but there's lots of ones that you can practice from on that vector addition worksheet that we didn't do. Okay, right at the beginning, like questions 1 through 4. Okay, we didn't even do any of those. You can practice those. The answers are there. Okay. All right, I would like you guys, let's finish off with the boat question number 3. Okay, I want you guys to draw and solve that one. Okay, I'm just going to put the diagram up here, guys.
So to get our resultant velocity is just a Pythagorean theorem calculation, 1.6 squared plus 4 squared. Okay, that's going to give us our 4.3 meters per second. And then to get theta, trig calculation, tan to the minus 1 of 1.6 over 4, which will give us our 22 degrees east of north. Okay, this one actually makes a pretty easy boat question because we didn't have to calculate the time. It told us it was 3.5 minutes. We didn't have to go, oh, the river's this wide, which they didn't tell us. Okay, so we just have to go, all right, well, the distance downstream will be d equals v times t. Okay, and so that will be 1.6 meters per second downstream times 210 seconds, which will give us our 336 meters downstream. Okay? Everybody all right with that one? Okay, tomorrow I'm going to give you your assignment on vector addition. You'll have the entire class period tomorrow to work on it. I realize it's Friday, it's a shorter period, okay? But you'll have the entire class period to work on it. And I'll come up with a due date. Okay? That's the plan for tomorrow. Next week, we'll start graphing.